Curon Davies, who works for the Regional Support Centre in Wales, is going to be talking about using DNS as a way of traceback for DDoS attacks that he experienced.
Okay. I work for Jisc RSC Wales, which is funded centrally by the same, Jisc, who also fund Janet, and we provide support for providers within Wales. One of those providers is colleagues here, which have been under not far off daily attacks, which initially posed a few problems, but with a little bit of help from Janet, and us, and some of that was mitigated to provide continued service. But the attacks were continuing to happen, most of them quite small, so weren't affected, but they were not far off daily. There are many types of attacks, but most of them were very similar, so we're just going to go through a few of them later. So, Colleagues here, further education provider based, headquarters near Llanelli. About 10,000 students, which we suspect one of them is the culprit, but we're not entirely sure about that. Someone's got a motivation, someone's got a grudge against the college, or some member of staff possibly. So we suspect it's one of the students, but we're not 100% certain. 2 gigabit feeds to different sites with a private circuit between the two. Most traffic is about 10 to 20 meg normally, but yeah, sort of full pipe full. There's a few DDoS service providers that you can just go onto one of those sites and pay a small amount of money and you'll have an attack sent directly at whatever host you provide. It's quite interesting. You might want to look at the NS and the A records for some of these, because some DDoS protection companies like to provide service, possibly a vested interest there. But they could also be traps to catch people, but unlikely, I guess. Most attacks are against IPv4, although we have seen DNS queries which have asked for quadruple A records, but due to various reasons, the college doesn't have there is an IPv6 allocation, but it hasn't been routed for a period, and when it was routed there were other issues, but we have looked at it but haven't actually used IPv6, so everything's been against IPv4. It's quite interesting because things such as low orbit ion cannon, in the documentation there's an example there. Looks like the code only targets IPv4, but I might be wrong, but most of the documentation is all about IPv4. As you can see, it's target IP. I don't think it does host name, but from the documentation, someone does the DNS lookup, and they target that, what A record they get from the DNS lookup. So, right at the top, the botnet controller, or the source of the denial of service attack, does the DNS request. And what we've done, inspired by GeoDNS initially, was to return different IP addresses for different queries. Initially we did different IP addresses for different country codes. There's 251 different country codes in the Maximind GeoIP database, so /24 dish a different IP address out for different hosts. We moved on for that, but I'll come back to that a bit later. Tracing which IP address was attacked was a little bit of a challenge at times, because logging, we've lost some logs, or for various reasons, disks being filled up, particularly with syslog of every single packet that was being rejected. That was filling up disk very quickly. Ended up moving to NetFlow, which was set up with the aid of Janet initially, but we were using pfLOD, which is part of the, well, the college are now using pfSense on the border, but originally Sonic Wall, which didn't cope very well. But moved over to pfSense, used pfLOD to provide the net flow, but pfLOD only provides the states that it manages. So anything that's dropped is not in the net flow. So we ended up setting up softFLOD in addition to pfLOD to different net flow collectors, one being sent to CSERP Janet and the other being sent to a local net flow. So the softFLOD net flow has been quite useful in identifying most of what the attacks are doing, but it hasn't provided all the details, but it's provided enough information about most of the packet. So some recent examples, 5th of March. Traffic for this was only about 2 or 3 meg, but 150 packets per second. Suspect that we're not seeing all the packets for various reasons. Probably the CPE is probably not up to the job, as you will see in the next attack. 2 attacks there, one at about 1 AM in the morning, another about 8 AM. Not many DNS queries during this time, but due to, probably should mention that as of about February, we moved from GeoDNS to setting the IP address based on the last octet of the source IP address of the query, which is quite evenly distributed. But I think, no, 5th of March was just before that, so that would be country code. Closer look at that attack. So started just after 8. The timing on pfSense was slightly out. The back-end NetFlow decollector, the NetFlow collector and the DNS servers had correct time with NTP. So looking at the 5th of March attack, the TTL of all the packets, all pretty much the same TTL, so it's pretty much guaranteed to come from the same source. Probably a TTL of 255, 256, the maximum available in IPv4. You're probably aware that most TCP stacks have the TTL on operating systems as either 64 or 128. I don't think there is an operating system that uses 256 by default. So looking at the DNS queries over a period, I've anonymized 2 of the attacks, but the rest are there. Dedicated server in the UK, so if you've got an IP address starting 178, you might want to ask later. This has actually matched up with nearly every attack I discovered yesterday. But it wasn't the source of all the attacks, which is interesting. The requests do not match up with anything else, and it's not clear there, but the attack was against the secure.colleagues.ACDK, which is used for logging in passwords, not used for anything else, I don't think. Moving on, so yeah, as I mentioned, GeoIP is rather biased towards 2 countries. Most of the attacks, although we did have a few issues with, we were using PowerDNS with a custom pipe backend, which I wrote. The backend was fine, but the default configuration in PowerDNS is to cache queries. So in the first few attacks, we thought they were coming from Pakistan or I think it was Brazil, but looking at it further, they were because it was a cached IP. So most attacks were Germany and the US, according to GeoIP, but the attack was actually possibly Google. Those 2 IP address blocks there, Google used for the public DNS service lookups from Brussels, or else I spelled it wrong there. So looking at the country code, I think there's only 52 countries that we actually distributed. Most of them US there, about 1,000 lookups in a short time period. Germany and the UK not far behind. So using the last octet was quite evenly distributed across all 256 addresses. Quite interesting that there's not many DNS servers running on IP address .0, but there are a few running on .256, sorry, 255, which, so we ended up setting up pfSense to just net forward all the IP addresses rather than having them on the actual back-end host. So because everything was coming from Google were very helpful. So we finally enabled the EDNS client subnet, which is a nice feature of that PowerDNS and one of the DNS service supports, which if you enable it with Google DNS and OpenDNS, you will get the /24 of the client that made the request. It's mainly aimed for Anycast and GeoDNS, but we were using it to try and trace the source of the attack. With IPv6, which we have tried, but not many people are using the Google IPv6 addresses. Everyone's using 8.8.8.8, which is easy to remember, or the other one. The IPv6 address is a bit long-winded and not easy to remember. So I think it was only our test request that was added over IPv6 to Google Public DNS. With IPv6, we get the full /64, which is quite useful. We had looked at IPv6 and we have the code to do IPv6, which was based on putting the host identifier in the interface identifier. So every attack would lead straight down to the full /64 subnet of where the attack came from. So another attack on the 11th of April with this octet-based DNS distribution. So late at night, about just after 8:15, another request from the earlier request just after this started, but yeah, so that was about 40 meg. This was a UDP 3 gigabit attack. Bearing in mind there's a 1 gig link, we could only see about 36 precisely megabits per second on the pfSense, and the load was quite low. I suspect it's the CPE or something upstream. 150,000 packets per second, mostly 40-bit, byte even. Yeah, so one request, precisely, well, just over 7 seconds before the attack started. It was the only, so those are the requests from for the entire day prior to the attack. That was sent, given an IP address ending in .147. I have anonymized these with documentation space, but one attack, which was 7 seconds before the attack started, was from a UK VPS provider, different from the dedicated server provider. Yes, another attack last week, which we barely noticed, as you can see there. The processing, this is how the attack was noticed. The processing was very low, but there was a bit of a blur between, I think it was 26 minutes past 2 and, no, 23 minutes past 2 and 24 minutes past 4, so a 2-hour attack. Barely see it. Bandwidth was quite tiny too. Could see something with the number of packets per second, but wasn't that abnormal as being about 5,000 packets per second. But if you looked at the state graph, it jumped up to 300,000 states. This was a HTTP stateful attack. Looking at all our logs, we have possibly identified 36,000 compromised or infected hosts. Most of them in the UK, UK, bizarrely, or America. We've gone through the list, which doesn't seem to match up with possibly any botnet that is known, which is a bit interesting. But they do look like compromised hosts or infected, mostly hosting dedicated servers or VPS, etc. There don't look like to be many consumer broadband type connections there. But most of them seem to be with one well-known box shifter, shall I say. About 10% of the attack came from there. So, are there any questions?
Ray Bellis. Sorry, no. Ray Bellis at Nominates. Oh, I've put it down again. There we go. You said. No. One. Oh, okay. You said that the TTLs indicated a single source, but yet they were spread across sort of 3 different TTLs.
It might have been 3 different sources, but they could have been via different routing. There were different TOS headers on the packets. Some were hex 28, most were 0, and there were a bit of hex 8.
So likely actually 3 different sources then rather than just the one?
There might have been 3, but there weren't many hosts.
Yeah. Okay, thanks.
Any other questions? Okay, thank you very much.